chapter 2 review is on rational expressions. That's allowed to working with all your fractions. So we're just going to go through like all the different types, like whether what you do when you add, subtract, multiply, divide, and all that stuff. So the first big thing is when you're adding and subtracting fractions, make sure you guys remember that you need to have a common denominator whenever we add or subtract. So in our first problem, what is the first fraction need? 2. Good job. Very nice. And when you guys are doing your multiplication, right, just watch your distribution. Make sure you bring that all the way through. So it should be 10x plus 6 over 2x. Now, once we have a common denominator, we can take the numerators and bring them together. But this is something they're going to try to do in the Regents to trick you. Watch out, this negative sign goes to both things. Right, so you need to distribute that negative through. So what we get is 10x plus 6 minus x plus 1 all over 2x. Your denominator stays the same. Okay. So keep that the same. Now combine all your like terms in the top. What did you guys get in the top part now? Good job, Nicole. Get 9x plus 7 over 2x. And if these can reduce, we want to reduce. If we can't, we can't. That's it.
Will Zach Hansen please report to room 305? Zach Hansen.
Good, Dad. Kind of looking familiar, hopefully. Same deal with the next one, just a little bit more complicated, I think. Everybody always gets this kind of a question wrong because they want to, when they make a common denominator, they always want to just like minus 3, right? We can't do minus 3 here because a common denominator has to be made by multiplication. And if we did minus 3 here, it'd be a negative 3x, not x minus 3. Do anybody remember how you make a common denominator here? Yeah, that's a nice job. Good, and then this one's x minus 3. Yeah. Good work. Think about it. What one fraction has, the other one needs. So they kind of like flip-flop. Nice work. So let me move this on your screen. When you guys go to do your multiplication, x times 5, you got 5x over x minus 3. Then this is going to be really tricky. I would group the minus sign with that 1 and just bring the whole thing through. That'd make it way easier. So then this becomes a minus x and then a plus 3. Good. And the denominator stays the same, so it's still x minus 3. The last step is to just simplify the top. So here when we combine our like terms, you should get 4x plus 3. In simplest form, we just want to make sure we put this factor x squared minus 3x. No more parentheses. They all kind of look the same, so just be really careful when you're checking multiple choice. Because you're really sticking the space. So division, do you guys know your rule for division?
You got a factor here.
Close, before we factor. Just so we're going to have to do some factoring.
Oh, you have to copy, change, split.
You got it. Good job. Copy, change, split. Good work. So copy, change, split, or you might hear like multiply by the reciprocal means the same thing. And I like doing that before you do your factoring. I should probably, I can't flip this. Just because if you factor first, sometimes you lose the pieces of what you factored. So I like to copy, change, split first, and then deal with it. So copy your first one. Change division to multiplication, and then we're going to flip the second fraction. So 2x squared minus 5x minus 3 over 2. So then, once it's all copy, change, split, then we're going to go through each part and factor what we can. When you guys are factoring, we did a lot of that last review, right? Remember, we're looking for like GCF. We have perfect squares, difference of perfect squares. Right? You might have to do your binomial with the double bubble or your grouping. And those are all of our factoring needs that we know, so. What do you guys think for your first cat card?
2, and bubble x minus 1.
Awesome, GCF, great. Down here?
X minus 3 and x plus 1.
Perfect. Good job. Alright, this one looks a little bit easier. What's your GCF here? 5. Good. And then we have a 4 minus x. Good.
Does it matter if you like change?
Yes, it does. If you want it to go in order, because if you take 20 divided by 5, you get 4 left.
Okay.
Same thing here. Because the reason why the order is really important is because subtraction's not commutative. You can't just like flip it around.
So what do you have to do with negative 1?
Yeah. Right. This top piece is going to be one of the harder ones to factor because we have a 2 in front of the x squared. Right. We did this last time, the grouping method. You guys were all here last time too, right? So grouping method, we did the outside. So we get -6. I'm going to do this over here so it's easier when I go to put it back in. And we want to get a -5. So you want to think, what can multiply to -6 but make a -5? Good, 6 and 1, I see. Good. -6 and a +1. Nice job. So what we're going to do is we're going to take out, we want to take out the middle piece. So let me put it down here again. 2x squared minus 5x minus 3. So we're going to take this part out, and we're going to replace it with you guys do your replacing. We have a 2x squared minus 6x plus x minus 3. And then we split it down the middle and did the GCF of each part. So your GCF over here, anybody know what it is? 2. Good. And x. Good. And we have an x minus 3 here. When you guys do your grouping, it's really important. You take out the sign, so it's a positive. What would be the GCF here? Good. 1. Nice. And then we have an x minus 3. So the bubbles are the same. And we're going to take the 2 GCFs, bring them together. So 2x plus 1. And then x minus 3. So these are what it should be when we factor. So way up here, we have to do all this work to find out how we factor this. So now I know that it should be 2x plus 1 times x minus 3. Okay. All right, so once we do all of our factoring, now we can go start looking to cancel. So anybody have one that thinks I can cancel? Good job, those are gone. X minus 3s are gone, like it.
X minus 4 and 4 minus x squared.
-1. Good job. This is going to come up somewhere on your Regents exam where you have the same thing, but it's reversed with subtraction. We can cancel it, but you have to leave a -1. That would be as like a multiplication in the numerator. Okay. And then anything else? I don't think so. All right. When we get done to finish this, we have 2 times -1. What could you guys make that? Yeah, make that like a -2. Then we have times 2x plus 1 from this side. And then on the bottom we have 5 times x plus 4. Now if nothing else cancels in here, take this and bring it through. Okay? Just depends how they ask you to leave it. If it's multiple choice where it's still factored out, that's fine. But symbols where I'm going to put it back through. So -2 times 2x is going to give us -4x minus 2. And then over 5x plus 1. And then that would be it. You want to like always factor in to make sure nothing cancels, but you can't. How's your factoring stuff for you guys? Right. Now you might see this as like a 6-point or something similar. And if you guys have mixed properties with multiplication and division, do that copy change flip first. But the copy change flip only applies to this part. So what we do is change this to multiplication and need to flip just the fraction that's after the division sign. can copy everything you said. Is there a sign? How does the copy change both sides? Oh, good.
Yeah.
Alright, so go through this and you guys want to factor everything possible. Anything that you think could be factored, let's do it. The first one, hopefully we're doing difference of perfect squares, x plus 3, x minus 3, because we have two perfect squares with the subtraction. This one should be a GCF. Just want to make sure. In here we should have double bubbles, factors of 10 that make a 7 would be 5 and 2. That's it. And then down here, we need factors of 18 that make a 3. So 6 times 3, you want a minus 3, so that is a minus 6 and a plus 3. This next one's a little bit tricky. Did everybody get the GCF here? 2. So 2x squared, and then we should have x minus 6. Alright, so let's go with this one, x. Factors of 15 that make it 2? Minus 6. Okay. You want to factor it out? Let's go through and we need to get rid of everything that we can. We got x plus 3, x plus 3, x minus 3, minus 3. So this should go to 5. We've got another x plus 2. There's x minus 6 can go. What about the 2's? Can we cancel the 2 here and the 2x? Can we do that? Yeah.
Yeah.
Yep, so then the only thing we have left is just, oh gosh, all that work for just x. That's it. So that's a lot of work for just x. It might be something like that as your 6 point. It hasn't come up in a couple years, so it definitely could be something that like recycles in. Yeah. Usually they'll put something like a little bit harder, like a grouping method that we did last chapter in like with the factor. All right. Now these two are a little tricky, and everyone always forgets when you use the steps for fractional equations. A fractional equation is kind of like adding and subtracting fractions, except it has an equal sign. So the idea is a little bit actually easier. We still want to get a common denominator, but you have to make sure it's on both sides of the equal sign. So across the entire bottom, we need a common denominator. Yes, this is where we just cross out. Good. So sometimes factoring first might help you identify what you should have on the bottom. So x squared minus 9 is really x plus 3, x minus 3. By doing that first, it might help you guys see that each of my fraction needs both an x plus 3 and an x minus 3. So this one needs the x minus 3. And the middle one needs an x plus 3. Now, once you guys have that common denominator, if you can look at it and you see that they all have x plus 3, all have x minus 3, we can get rid of the whole denominator. We're just going to be crossing it out. Then we're going to solve the top like a usual equation. Right? Just watch the negatives in the distribution, because that's how they're going to get you. We need to bring this through. 2x squared minus 6x plus, bring our 3 through. 3x plus 9 equals 8. Alright. As soon as we see something with an x squared, what do we need to get this equal to? 0. Good job. So we're going to combine them in like terms, and we need to get this thing to 0. So now minus my 8. And we take it all out, we get a 2x squared. Negative 6x minus 3x is a negative 3x plus. That'll just give us 1. Nice. Alright. We can solve this a couple ways. Does anybody in here use guess and check? No, we all do grouping, that's fine. This would be an easy one to guess and check, because there's only one set of factors for 2, there's only one set of factors for 1, so it'd be an easy one if you wanted to guess and check. If you did guess and check, what way would you guys have to solve? Grouping, yeah, good job, because you have a 2 in front of me. So if you wanted to do your grouping, you could. So if we take these things that multiply to 2 but can make a -3. 2 and 1, no, they're only options. What do they both have to be? Negative. Good job. Very nice. We're going to take out this -3x. We're going to put these 2 in a swap. So 2x squared minus 2x minus 1x plus 1. We're going to split it down the middle and do our GCF to both sides. 2x minus 1. And here, make sure you guys take out your negative as the GCF. Right, and that'll make your sign switch. So then our bubbles are the same. So we have 2x minus 1. We join the two GCFs together. And then we write the bubble 1 time. Common sign with no.
Would you say that equals 0?
Not quite yet. One more step. What do you set them to? Yeah, you could set them each separately to 0. Good. Alright, so when we set them to 0, we have 2x minus 1 equals 0, x minus 1 equals 0. You guys might probably do that one in your head. So here we're going to have x equals positive 1, and when you solve for x over here, it's going to be a 1 half. Now the last thing, and if they really want to be mean, okay, you want to check for undefined. What I mean by that is to make sure you don't have to reject any of the values. What makes something undefined? In the bottom, good. So we want to make sure if we put one of these x's in, we are not going to get a 0 in the bottom. So let's check out what we have. We have a 1 half and a 1. Alright, so way back up in the top. Alright, so if I put a 1 in here for x, will that give me 0 anywhere? No, so it's fine. What else if I put a 1 half in? Will you get 0? No. Okay, so both of these work. But if you got like a 3, that would not work because it would have made a 0. So you have to make sure you check these because sometimes they will be nasty. So both of these are good. They check. Do you guys want to do another equation one? Sure. I need to make more space. Do you guys have enough space?
Yeah.
That's right there. So we have an, make sure you really focus that you have an equation, because that's how you can kind of tell that you got to get the same denominator across both sides. Are you guys, what are you making all the bottoms become?
X squared plus 2, or
X squared plus 2x. Good, good. They all need an x, and they all need the x plus 2. Good work. Okay. It's a little bit tricky because this last one needs both things. It needs the x and the x plus 2. It doesn't have to look great for this. You just need to make sure they all look the same, then you can get rid of them. Alright, so x times 4 is going to give us 4x squared. Watch out for this little negative. Right? They really like to throw that in. Alright, it's just a simple place they can mess you up. So we have then a negative 12x minus 24. And then same thing over here. You guys could do this in like 2 steps, 1 step if you want. You're really taking a 1x and bringing it through. But 1x is really just x, right? So if you took this x and you brought it through, we get x squared plus 2x. Good. So this is very similar to the last one. X squared is our highest exponent, so we need to get this to 0 first. Maybe this will be a nice one for us, but it doesn't look like it. Alright, Do we have a GCF at all? This one right here?
No, it's a negative 12x and a minus 2x.
Oh, negative 14x, yeah. Okay, good, thank you. Out of it. Oh, no, still GCF, alright. I was hoping we could take something out of it. Alright, so to solve for x, we can only do the grouping. I'm going to do it again. They'll try to throw a lot of grouping on there for you guys, but it's a harder way to factor, so. Let's see. So 3 times negative 24, what's that going to give you guys? Negative 72, good. And then we want to make a negative 14. It's a little tricky. Things that multiply to 72. We try 9. Oops, I do 78. Oops, 72. And 9 and 8. Okay. Do you guys know what? You got it? You got it? Oh, it's just going to be these, I think. Oh. 72 divided by 4. Oh no. Whew. So we're going to have to use quadratic formula. Right. Can 4 and 18 give us a 14? Yeah. Okay. Now, this is a good thing though. If I could not get anything that worked, can't you use quadratic formula? So, you can't factor. It's always an option when you're trying to find x. Okay, so we have 18 and 4. Which one needs to be the minus? 18, good. The only way we can get a negative 14x. Alright, so let's get rid of our 14x. We're going to take that out and put the other ones in. Put it down the middle, and then 3x is 6. So you can go from here, make sure you take the sign out with that GCF. Both the same, looking good. 3x plus 4. X minus 6 just one time. And then we have to set these to 0. And when we do, we should have x equals to negative 4/3, and then x equals 6. How was the solving part? Good. Okay, let's just check and make sure undefined. We don't have anything. Okay, so we have a negative 4/3 and a 6. Look at the bottom of this. If I put in a negative 4/3 or a 6 anywhere, will that give me 0? No. So those are both fine. If we got a negative 2 though, then we would have been in trouble. So these are both okay. The last little section on complex fractions. We've done a lot of these. I don't know, why is this together now? So when you guys have a complex fraction, your goal is to make a single fraction in the top and a single fraction in the bottom. So we want to work with just the top first. So look at this section. How do we add fractions? What do we need? Common denominator. Good. So that should be the first thing to get a common denominator.
No, yeah, you said you did.
Oh, that's right. Alright, so this one's going to need an x, this one needs a 4. So when we make a common denominator and we get a single fraction, we're taking 3 times x, which is 3x plus 3 times 4 is 12, and then we keep the bottom the same, so 4x. That's what I mean by a single fraction, not like split up. So then we have to do the same thing with the bottom down here. Get a common denominator. This one's going to need a 4. This one needs an x. When we do our multiplying, we get 4 plus x over 4x. How's this so far? Okay. All right. Once you have it all set up, we've done this a lot with copy change split. So 3x plus 12 over change that division sign to multiplication, flip that bottom. Right, and this turns into really a multiplication problem. So when you guys were doing your multiplication, make sure we factor everything that we can, and then we want to cancel. Does anybody know how to factor this 3x plus 12? Great, 3x plus 4, awesome, okay, good. Now, once everything's factored, let's get rid of some stuff. 4x and 4x can go. Can we cancel x plus 4 and 4 plus x? Yes, good. Because addition is commutative. We don't have to leave the -1 with addition, just the minus if it looks like that. So the final answer is just 3. Great. Next one. So expressing this in simplest form. This one's kind of nice because see how the top is already a single fraction?
So you don't have to do anything.
Yeah, you don't have to do anything. So it's already there. It's great. So I'm just going to rewrite that. X minus y over y. Now the bottom though is 2 fractions, so we need to get a common denominator here. One side needs an x, the other side needs a y. Once we get our single fraction, we're going to have to change both again. X minus y over y times xy over x minus y. And can we factor anything here? Yeah, go to the other one. I see. Good. So just cancel those. What else? Y. Great. So just get x. Super. Good job. All right. So I hope chapter 2 you remember a lot of stuff.